What I hope to do in this video is give an intuition for why one of the most important differentiation rules, the chain rule, why it works, why it makes sense, and why it would be logical. This is not a rigorous proof by any means. This is just a sense of what is happening every time we are differentiating using the chain rule. So after introducing the chain rule, I want to do a couple of practice problems to give you a good sense of how this rule actually works in action. So suppose we had the function y equals 6x minus 10. So just consider this function here. And the first thing we notice is that we could probably write this function as a composition function. That is a function that is made up of another function. So let me actually just do that. Let me go ahead and rewrite this function as y is equal to 2 times 3x minus 5. So y is equal to 2 times 3x minus 5. All I'm doing right now is factoring out the 2 and rewriting this as a function of a function. And ask yourself, what is this inner function here, if you will? So this can be thought of writing this as y is equal to 2 times u, where u is equal to 3x minus 5. So all I'm doing right now is writing this original function as a function of u. Now, let's take a moment and let's actually differentiate some of these functions here. Let's take a look at these derivatives. First off, let's find dy dx. What is this? This is the derivative of y with respect to x. That is, we are going to be differentiating this function here. It's a derivative of y with respect to x, which is, in this case, if you apply the power rule, or excuse me, it is the power rule, I was correct. It would just be 6. All right. Now, next, let's take a look at the derivative of y with respect to u. dy du. What is that one? Well, the derivative of y with respect to u, we would be differentiating this function here, dy du. This would be equal to 2. So the derivative of y with respect to u is 2. Again, and what we're saying is the rate at which y is changing with respect to u is 2. And finally, let's differentiate du dx, again, which is the derivative of u with respect to x, which is now, if you will, this function here. So let's write this as just 3 using the power rule. Now take a moment and look at these values, these derivatives that we just found, and see if there's a relationship between them. Well, it's pretty clear. We can say that 6 is equal to 2 times 3, right? And so what are we actually saying here? We're saying if we substitute their equivalent derivatives, we'd say dy dx, so the derivative of y with respect to x, it turns out it's equal to dy du, which is what 2 was equal to, times du dx. And this, my fellow mathematicians, is exactly what the chain rule is. This is the chain rule. Now, before we really dive right into what we're saying here, let's just make sure that we establish a few things. First off, yes, this is the chain rule, and I'll break that down in just a moment. But what we just did is we found the derivative of all of these functions with respect to their independent variables. And what we saw was that dy dx is indeed equal to dy du times du dx. And at first glance, this just looks incredibly coincidental. It just seems like we almost arrived at this by accident. But if you actually break down and think about what we're saying here, this is actually very intuitive. What is a derivative? The derivative, one way of thinking about the derivative is stating that it's the rate at which something is changing with respect to its independent variable. That is to say, right now, in this original function here, what are we actually saying? By finding that the derivative is 6, we're saying that y is changing, in this case, 6 times as fast as x. Y is changing 6 times as fast as x. Well, and if we break down what's happening here with these individual derivatives, we can say the following. We can say, all right, if y is changing twice as fast as u, let me just highlight this again. If y is changing twice as fast as u, and u is changing, what do we say? 3 times as fast as x. If u is changing 3 times as fast as x, then it makes sense then that y is changing 6 times as fast as x, right? If the inner function, if our inner composition function that we have right here, if we see within this inner function, which we defined as u, if that's happening 3 times as fast as our independent variable x, then it makes sense that our outer function y is then changing 6 times as fast as what's happening there. And this is the key idea behind the chain rule. It's the idea that we're differentiating a function that can be thought of as a function of another function. And by differentiating, another way of writing the chain rule here is to say the following. We might say f, if we have the derivative, let me actually restate this here, the derivative of some function with respect to u, where u can be another function, where u is another function, then we can say that the derivative of this function, the derivative of f of u, is f prime of u times u prime. That is to say the derivative of the outer function times the derivative of this inner function. And intuitively, this makes sense because some change to the inside or to the inner function should cause a change to the outside. Let's try this example again, or I should say, let's try a separate example, but kind of operating in the same vein or thought process so we can make sense of this. So let me go ahead and change colors here, and let's try something like this. Okay, so let's think of a function like y equals, and that's not straight, and that's going to bother me. There we go. Y is equal to something like 25x squared plus 10x plus 1. Now, try to think about this as a composition function. How can we rewrite this so it's a composition function? We would say y is equal to 5x plus 1. This is one way of doing it. This is not the only way. But this is pretty easy because what's nice about this is we can rewrite this as y is equal to u squared, where now u, our inner function, is 5x plus 1. Well, again, let's find the derivatives. Let's say dy dx. Now, the derivative of y with respect to x, so we're differentiating our original function with respect to x, that would just be 50x plus 10, which is also equivalent to the following, 10 times 5x plus 1. Now, what is dy du, the derivative of y with respect to u? That would just be 2u. The derivative of u with respect to x, let me make that u a little cleaner, u with respect to x, this here is just equal to 5. And let's actually rewrite 2u because I want everything to be with respect to x in just a moment. This is equivalent to 2 times 5x plus 1. Now go ahead and look at the relationship between these. We can say that 10 times 5x plus 1 is indeed equal to 2 times 5x plus 1 times 5. In other words, dy dx is equal to dy du times du dx. To find the derivative of our original function y with respect to x, it is equivalent to finding the derivative of this function with respect to our inner function times the derivative of our inner function with respect to the original independent variable x. The derivative of the outer times the derivative of the inner. Okay? In the next video, I'll just do a couple of practice problems with the chain rule, but hopefully this gives you an intuition or just a logical sense for why this rule works.